your, endpoints. Providers, which is all the services, and basically all the logic. And then you can import everything and export everything. So you can import module between the applications and you can export it. So some modules can be exported and used by other modules. And some modules are maybe not the ones that you want to export. So again, you have a full control how your application is structured. So which is, I think, pretty cool. And of course, the maintenance injection, right? We are writing into the interfaces. So interfaces are everywhere. And again, the whole concept is, is great. And, it just working with Nest, it will force you to have good practices, which is quite cool. Then CQRS, right? So what's the CQRS? So it's basically, comment and queries, right? It's not, basically, it's very simple, right? So some of the commands will actually change the data, and the queries will basically query the data, right? So that's the whole concept. But it actually has some great implications, right? Because usually when you want to change the data, you want to have some complex business logic to apply, to those commands, and then you can build it, right? And then if you query the data, usually you can go straight to the, to the database. Of course, in some situations, the read model and the command model, the query may be different databases. But of course, for the smaller applications, it can be, the same database, which still allow us to, to use this pattern. We are using this pattern everywhere, right? It's not only for the complex project. It's also for, for those small projects. We are trying to always use CQRS. And event sourcing is not required to use CQRS, right? So I think this is also very important. So in this example here, I will show you the event sourcing, but it is not required to use event sourcing with CQRS. And of course, the clean code, this is something that I already told you. So the components, right? So we have the command, so the command handlers. So the command handlers are basically the commands that are changing our system state. So this is the business logic, and basically, if we use the command, that means that we are changing something in the database, right? In the event sourcing, we are not changing the database; we are adding records, but basically we are changing, the system state. Then the query handlers are the components where we are only requesting, the state of the model. So again, it can be light, and it can go straight, to write a SQL, for example, and or other method. Then we have the aggregate. So we already talked about the aggregate, more or less what it is, and here's the same concept, right? We have aggregates on the backend, and this is some part of of the business where it's like a unit of the business, and then it's a unit of change, right? So we need to keep it together. And again, it's like the class. And then we have event handlers, and in Nest, it's called sagas. So basically, those are the listeners for the events, and then we can actually just execute more commands based on the events. So this is basically how it works. So the event sourcing. So who's done event sourcing? Who know what is event sourcing? Okay. Cool. So we have few people. So again, the concept is very simple, right? The concept is very simple with the event sourcing. So the event sourcing is about the events, and the events is basically some state of the applications that will not change, right? So basically, we are adding the events on top of each other. We are not updating the database. It's only the inserts. And that's the idea behind it. So we have the full history of the changes, right? So because we are not updating everything, we are not deleting everything, we have the full history of the changes, which means that that we can always repeat something, and and if, let's say, if it breaks, we have ability to actually repeat all the events and go to the point in time in time of the application that we want. Of course, for some cases like the banking industry, finance industry, audit trail is very important because again we are not deleting everything; we have the full history. But what is the problem with the event sourcing? The volume of data. Because we have a lot of data, and let's say someone wanted to start event sourcing for the store, right? So if you are opening the store, you are starting the events for the event stream for your maybe cashier. So then after a year, after 2 years, after 3 years, you have a lot of data, and that's the problem, right? So that's also something that you need to think about, and make sure that your event streams that are the parts of the events that you are working on are as small as possible, because if you have 10 years of data querying it, it's not. It will probably blow up your system. And of course, there are different problems like schema evolution, right? So this is something that you need to also think, because the system is always living, it is changes, and it is changing. So you need to take it into consideration. And event sorting is not good for everything, right? So it's not like something that we will always use. But in some cases, it is something that is worth thinking about. And also important part is that you don't need to have the whole system in event sourcing, right? You can just pick the part of the system where it is suitable, and then you can apply it over there, and the rest of the system can use different architecture. So with the Nest, as I mentioned, Nest supports the event CQRS out of the basically from the framework. So in the Nest, we have actually the class which is aggregate root, and it represents the current state of the object. With the event sourcing, to be able to get this current state, we actually have to apply all the events that we stored to be able to get the current state. And also other techniques, because we can apply all those, of course, events, but we can have actually some read models that will give you this, that will give us this the latest states. That has to be like also the background, the background job. So depends on on your needs, but basically we need to have those events to have the current state of the object. And then the actual methods. We need to apply the event. So to apply the event, oh, sorry. Right. So so we have apply. So we are applying the event to the aggregate, and then it will basically update the state. We are committing. So after committing the state, you actually some other events will be published. We can get uncommitted events, so that's basically like just the method over there. We can have auto commit, so every time we apply the event, it can be committed. And then we have a method called merge object context, which basically takes your aggregate and it will add the publisher to be able to publish those events. So I will show you this in the code, and hopefully I will actually run some code. So we will see how it works for me. So, and the sagas. So the sagas are, this is the running process. It's running all the time, and it is listening for your, for your events, and it's execute commands. And the cool thing is that you can actually, write some very complex logic in the sagas, and execute some, some functions one after another. So this is pretty cool. I'll show you some, few tips and tricks about like, free cases. And then everything here is using RxJS. So it's worth to get familiar with this, with this library. So with the sagas, so this is more or less how it looks. So we have, we have the saga, and we are listening for the event, and we are listening for the event X, and then if the event X will came to us, we are executing two commands, command A and command B. And in this case, both commands will be executed. So even if one fails, so just execute everything, right? So this is how it works. The second, the second type, maybe that we want to actually, execute the command based on different, on different event. So here we are listening for two events, right? So again, if we have a card validated event, something will be executed, and then we are listening for the payment process events, but they are not like connected to each other, right? So they are not checking out what's actually been executed before. And then we have the method to actually connect those executions. So we can execute the first command. So and then this command will actually generate us another event, success or failure event, and on this event we can again execute something else, right? So in this case we are actually connecting together, and we know like that. Okay, so this command actually executed, and then we can handle the next event. And then the last one that I wanted to show you is where we actually storing the events. So it doesn't have to come one after another. Basically saying that, okay, if I have this card validated event, just store it over there, and whenever the payment process event will come, I want to check some business logic. So here, like the last validated event is actually it's there, and then if it's there, do something, update the inventory. So in this case, we are actually again connecting the the card validated event with the payment process event to make sure that it's always payment process always executed with some business logic validation. So the demo also will be available on my GitHub, the code. And the demo that I will show you is basically the small application for trades. So let's say this is the part of the system that is doing trading for cryptocurrency, and basically it's simplified, right, for this demo. But what I do is waiting whenever I'm creating the order, the trade, then actually the command will execute this trade, and my Saga will emulate that there is some business going on. I don't know if the trade is filled. Usually it's not filled, whenever you just put the order. So actually, it will fill my order after some time, and basically that's how it works. And my create order handler that is handling my event command will actually use the API that I created and store it in the event store, and then apply those events to aggregate. So hopefully I will be able to show you some code. So basically that's my aggregate. That's my aggregate, and here is very simple, right? My aggregate, it has some kind of the order, and the order is of course the interface. We have some order, status, simple, but we have the interface to be able to work with it, and then we have the aggregate, and the aggregate root in this example will basically only set the data. Whenever whatever we give it, it will set the data, and then based on the action, right, it will create the order, and by creating the order here, it will only execute the event, after it's created. And the only, let's say here, the part here is actually building this order. So this is what I told you, that to build actually the order, to use it in the get, I need to go through all those events and build the order. So this is how it works. And then we have create command. So we are just using some DTO here, and then we have so this is where most of the logic happened, right? So we are saving it to the. So we are executing some API, right? So this is my very simple API that's created, but we are, let's say, executing some external API to create the order. Then we are saving the order into event store, and then here we are, we are working on our aggregate. So we are setting the data that came from API, and then we are pushing create order. In this case, right? Because as you can see, we have a set data and create order. So for more complex, let's say, examples, like production examples, you would add the logic also to create order, because here we are just setting the data and everything works, right? But you want to have some also validation over there. And then we are basically committing this, and this is how it works, right? So as you can see, the structure of the Nest project is also very important, and the trait is my module, right? So this is this is something that the guys talked about before. So we have a module, and we have some directory structure that is very clear for everybody. And the cool thing also is that whenever I'm thinking about creating the object, like creating my trait, I have basically very clear structure. I don't have to look around. It is, in my opinion, is very intuitive, and to onboard someone to this project will be very fast. And then in terms of the repository, we have event sourcing repositories, dedicated databases. But here I'm just using Firebase. So again, that depends on your needs. And again, so this is my module, right? So this is my trait module, and I'm doing some dependency injection. I'm doing some configuration, and I'm gluing everything together. And in production applications, we have many modules, right? We have trait, we have authorization, we have many modules to be able to get it work. And then we have the controller. So the controller, where is the controller? That's it, right? So basically, the controller will again, execute those commands in the bus. So there's a command bus and there's a query bus. So we'll execute it. It will go through all this, all those steps. It will up the database. It will create our our orders. So let me just try to run it and see if it runs. Okay, something is running. Right. So I want to send the request to create the order. So this is my, this is something I just configured in my controller. So whenever I send it, so the order was created, and here you can see that, there is some log. So, order created event was actually fired. And then after the order created event, because I have my Saga listening for those events, I have also order fill event. So I will show you the Saga. That's right. So in the Saga, I'm just saying, okay, listen for my order created event that is fired after I create the order, and then execute the command. And again, we are going back to the same cycle. I think it is quite easy to understand. So in my Firebase, what I have here, so this is this is just yeah. So this is So this is it. So I have my order. 2 orders actually, right? So the first event, it was the event with the full details when we created the order, and it's open, status is open, and we have all those information. But then, if you can see, with the field order, we have only the change of the status for for the given aggregate, right? So we have this only status field, and that's why we need to actually replay all those events, right? Because if we just get the latest one, we have only field, but we don't know we don't know more about this object. So basically that's how it works. And then whenever I need to get something, so let me just try to get it, the latest order. Okay. Here. Should work, I don't know. See. Yeah, so as you can see, we get actually the full order with the latest status. And over here, you can see that, we retrieve two events for this order. And that's how we build this order. So this is, this is how it works. And I think that's it. That's my presentation. Do you have maybe any questions? Yeah, go ahead. We can switch to Polish now, maybe.
I can speak English too, Dobra, to tak. Pokazałeś saga pattern. Ja zauważam, że jest bardzo potężnym narzędziem, ale zastanawiam się, co z runtime'em, jakby jak to wpływa na skalowanie tej aplikacji backendowej na jej reliability, bo jeśli trzyma stan tej całej sagi wewnątrz pamięci na pojedynczej instancji, to problemu nie ma w małej skali, ale kiedy masz bardzo wiele podów na klastrze, musisz pilnować na przykład, żeby konkretny request od konkretnego usera trafiał do konkretnego kontenera, mogą się zacząć tym problemy. I zastanawiam się, czy to w ogóle...
To co, mam powtórzyć, czy co?
Ja powtórzę.
Ale to był koniec pytania, w sensie...
Okay. Dobra, to nie jest, saga nie jest na cały system, prawda? Tutaj...
Chodzi mi o to, że jakby by default, kiedy używałem SAG, rozwiązałem zazwyczaj taki problem, że mam bardzo dużo stepów, one mogą jakoś tam się branchować w prawo, w lewo, bo coś tam może się nie zadziać. No i najważniejsze było to, że ta saga odwracała kontrolę i czekała za mnie, nie? Jakby ja nie musiałem się, jeśli mój workflow miało tam bardzo wiele stepów, że nie wiem, tam mamy jakiś właśnie system bankowy i on musi poczekać, tam card issuer, nie? Wizja, potem tam ktoś ci musi powiedzieć, że Bitcoin nie był wybrany,
ten sobie
nie?
trzyma i czeka na następny event.
I to może jakby ten cały workflow, czas tego wykonania workflowu może być tam nawet parę minut, nie? I tak się zastanawiam właśnie, czy spotkałeś się z jakimiś innymi patternami, albo jak to rozwiązujesz? I czy w ogóle jest problem w twojej skali, bo być może w ogóle nie jest.
Znaczy, ja tego problemu nie miałem, a problem jest taki, czyli jeżeli mamy sagę, no to jeżeli mamy tego patternu, gdzie ta saga sobie czeka na jakieś eventy, żeby coś wykonać, no to, że tych eventów nam się może nazbierać, tak, i po prostu to się stanie wolne. No to, znaczy, wydaje mi się, że tu jakby saga jest też jakby tutaj, możemy coś zrobić, tak, czyli możemy sobie to po prostu zapisać, te eventy, możemy to po prostu, jeżeli nasze serwery nam tutaj nie wyrabiają, no to po prostu trzeba użyć zwykłych tutaj tych technik, czyli outsourcujemy i później ściągamy z powrotem, tak, te dane, żeby rzeczywiście nam się to nie zapychało, no jeżeli mamy te problemy, tak mi się wydaje, ale też tutaj są te sagi per moduły, tak, także też nie jest saga dla całego nagle wielkiego systemu.
Dziękuję bardzo.
No, jeszcze może jakieś pytania? Tak, taki miałem tam mały kodzik, na moim prywatnym repo to jest dostępne, także nie wiem, gdzieś się pewnie będziemy mogli podzielić, prawda? Tak, no to wrzucimy. Proszę?
So you basically showed a really nice demonstration of the code that proceeds with the event and the event handling. But my main question is, what about error handling? How would you basically handle the operation of the commands in that terms of the CQRS if it fails? Because in your demonstration, there's basically no any like error or failure handlings. Always And especially when we have this type of the code, which does a lot of this functional stuff like filters, map, and the event after event, proceeding after proceeding, and also like the chain of commands. What if something goes wrong? How would your system understand which step have failed, or you're just failing the whole event and then you try to?
So it depends what you need, right? Because if you let's say if you need to make sure that the command will be executed, you need to use the queue that will guarantee it, right? You can put it on the rabbit. The rabbit will basically make sure that it will be executed at some point whenever the service is ready, right? Then the other technique is basically I think I mentioned on the sagas, you can actually rise the failed commands, right? So whenever something is failed, you are rising the failed command, and this failed command will do something, something else with this, right? So, and of course, with the rising the errors, that's we are doing it in the handlers, right? So that's like normal approach. So I hope that it answers your question.
Yeah. Okay. Yeah. Got it. Thank you.
No problem.
Answering to you, I had just the same problems in my systems, and I needed a very granular transaction rollbacks. If you had 7 steps and you failed on fifth, then you needed to revert 4 or 5 actions depending on what you did and where did it fail. So if you would like to have very small atomicity for one saga, those were only simple examples of saga where the saga was streamlined and it was a single flow of the program. But you can you don't need to use Rx streams per se. You can do in memory state management too. So you could do some operation and you could catch every error on every command. But of course, it is very hard to roll back, 4 operations in a row. So you need to keep track of that too. But it's generally hard, and it's not recommended that you have one super big saga that needs to be transactional.
It just also tends to be really complex application when you have a lot of data flowing and streamline, and also with error handling and all this stuff. Yeah, just I'm saying, all we try to do is manage the complexity, okay, the way we know. And when we try to deal with all these commands flowing and error handling, it tends to be really difficult not to just write the code that works, also maintained and make sure that this code is error prone and you can recover from failures, basically what I'm saying.
Yeah, and with with the Rx, you can actually also even with the Rx, you can make sure that this command at some point will execute, right? Because you will just just retry until it executes, if of course there is no problem if the data is problem with the service. Cool. No, I think there's one more question.
Tutaj użyłeś wbudowanego tego CQRS-a w Nesta i pokazywałeś taki jakby ten audyt, w sensie ten audit trail log, coś takiego. Czy to jest wbudowane, czy to był po prostu podgląd z Firebase'a?
To był podgląd z Firebase'a. To są eventy. Naszym trailerze są eventy.
Ale jak takich dużo będzie eventów, to taki audit log będzie ciężki w użyciu. Czyli są jakieś narzędzia, które są od razu też wbudowane w Nesta, z których można skorzystać?
Nie, ja nie znam, może są, ale ja nie znam. Ale tutaj właśnie to jest ta technika, gdzie tych streamów nie robimy dużych. Właśnie nie robimy streamy eventowe, sobie rozdzielamy na dzień na przykład, czy właśnie żeby one były takie dość granularne, żeby one nam nie wybuchały i nagle, żebyśmy właśnie nie mieli problemu, że tych nagle eventów jest 100 milionów, prawda? To jest jeden z największych problemów w event sourcingu, że jeżeli tutaj coś zaplanujemy, no to tego nie widać na początku, ale to będzie widać później, prawda? Już jak aplikacja sobie działa.
Okej, dzięki.
Super, to w takim razie dziękuję bardzo. I zapraszam.
Czekam, czy pizza już jest, czy jeszcze nie ma. No to słuchajcie, pizza jest już na dole, będziemy ją zaraz przenosić. Dzięki wielkie za spotkanie. Parę słów jeszcze na koniec, to było 10. spotkanie TypeScript.